Sorry everyone. Internet went away, so class got disturbed because of that way. When I reconnected it, so I hope I'm audible. You can see my screen. So I was discussing the concept of time and work. We did the problems related to the positive work, and then we were talking about the problems related to the negative work. So whenever we have positive, negative work, they are happening together. So when we have positive and negative work, when they are happening together, it can be a scenario where the sum total of the positive work it can dominate over the sum total of negative work or vice versa. So I came up with very good problem. You can understand this problem in much more better way. So here three pipes are there. Two are inlet pipe and one is outlet pipe. So the pipe A and B are inlet pipe. Pipe C is outlet pipe. A can fill the cistern in 4 hours. B can fill the cistern in 5 hours, and C can remove all the water from the cistern in 2 hours. So you need to understand that which is dominating. The sum total of inlet pipe is they are dominating, or the role of outlet pipe they are dominating. So whichever is dominating, I'll try to put with negatives. I'll try to put that with positive sign and other one with negative sign, so that the sum total of the final value I should get in positive sign. So here the question arises, the very big question what is come in our mind. You need to understand that that the speed of inlet pipe, the sum total speed of inlet pipes, so is that more than the speed of outlet pipe? Is this is more than the speed of outlet pipe, or the scenario can be speed of the sum total of the speed of inlet pipes, so is that is less than the speed of outlet pipe? So that will ultimately will determine the the final outcome of the event. So although you can understand from this problem only, you don't have to do this exercise. If you want, you read the question properly, you'll understand. Question is that when the system will get empty, so it means definitely there's no possibility of first scenario. You can easily understand that the second scenario is only working on the speed at which the outlet pipe is working, that is more than the speed at which the sum total of the speed at which their inlet pipes are working. So you can understand that part. So that possibility you can easily understand. So here better would be if I put this with plus sign, and it would be better if I put this with plus sign and this with minus sign. Okay. Then if I define the work as an LCM, if I can define the work as an LCM of 4, 5 and 2, so then my work will be 20 unit here. So then my work will be 20 unit here. So 4, 5 and 2 LCM. So if the total work is 20 unit, then every hour A is doing minus 5 unit of work, every hour B is doing minus 4 unit of work, and every hour C is doing 10 unit of work. It means every hour positive 1 unit of work is happening. Positive, I'll always make it positive here. Here, what plus sign means? Here, the plus sign means the speed at which the water is going out. Speed at which the water is going out. Speed at which the water is going out. That is your plus sign. And minus sign means speed at which the water is coming in. Speed at which the water is coming in. So here here the negative work or the rate at which the water is going out, I put that with plus sign, and the water when it's coming in, I'm putting that with minus sign because I know the final outcome. I know the system will get empty. So every hour, uh, 1 unit negative 1 unit of work is happening. Means if the total work is 20 unit, so every hour negative 1 unit of work is happening, or the system getting empty in 20 hours. I hope you can easily understand this. So in this problem, if you can understand in other way, if you do in per hour basis, if you do in per hour basis in term of percentage, every hour the inlet pipe, the first inlet pipe will do positive 1 by 4 part of work, 25% of work it will do. Thus other pipe will do 1 by 5, means 20% of work it will do, while this outlet pipe will do 1 by 2 part, means 50% of work it will do. Every hour, if you can understand, so 5% of the work is being done. So here the plus sign means the water is going out, minus sign means the water is coming in. So you can understand in total 20 hours the complete system will get empty. If you take a completely filled system, if you take a completely filled system, if you take a completely filled system and if you open all the three pipes together, then in 20 hours the system will get empty. And while if you take an empty system and then you open all the three pipes, then never the water is gonna go inside, because the rate at which the water is going outside, that is more than the rate at which the water is coming inside. So that part I hope you are understanding. So if the here in this question what is given, so it's not like you're opening all of them together or you're closing all of them together. Here in this problem what is given, that the system or the pipes are opened at different time interval. What is given according to this problem, the pipes are opened at different time interval. You can see they are opened in the ordered at 1 p.m., 2 p.m. or 3 p.m. So you first pipe you open at 1 p.m. First pipe, the pipe A, the pipe A, the pipe A is open at pipe A is open at 1 p.m. Pipe A is open at 1 p.m. The pipe B is opened at 2 p.m. Pipe C opened at 3 p.m. When you're opening them, you're not opening all of them together. You're opening them at different time interval. You're opening them at different time interval. Pipe A, you're opening pipe A. You're opening pipe A at 1 p.m. So pipe B, you're opening at 2 p.m. and pipe C, you're opening in 3 p.m. So you're opening them at different time interval. So I hope you're understanding. So now because you're opening them at different time interval, you can understand that A and B are inlet pipe and C is the outlet pipe. So the moment if you open pipe C, the water will start going out. Till the time you don't open C, the actually the water is getting stored. So you are opening the outlet pipe at 3 p.m. So before 3 p.m. Maybe 259.59, the part of cistern which is filled, part of cistern get filled. You can understand this. So the how much the part of cistern would have filled. So that would be means inlet pipe. Inlet pipe A has worked for 2 hours. Inlet pipe A has worked till then for 2 hours because they opened for at 1 p.m. and inlet pipe B, inlet pipe B has been opened for 1 hour till now. Has been opened for 1 hour till now. So pipe A has would have done how much amount of work? So every hour the pipe A do 25% of work. So it has done 25 into 2, 50% of work. Similarly, pipe C, it every hour do 20% of work. So the total 70% of work has been done. Okay, the total 70% of the work would have been done. Okay, so before you are about to open the pipe C, 70% of the tank would have filled by that time. Okay, and you can understand this, or if you talk in the term of unit, So this has work for 2 hours, so minus 10. This has worked for 1 hour, minus 4. So 14 unit of work would have been done. The moment if you open all three of them, then every hour 1 unit of work get destroyed. I hope you understand. So before you are about to open the pipes, 14 unit of work would have been done. The system won't be a completely full. System would be 70% full. I hope you are understanding. System would be 70% full every hour. If once you open all three of them together, every hour -5% of work will be done on the system. So if only C is working, then it is doing 50% of work. Because of influence of A and B, it end up in doing 5% of work. Okay. Otherwise, it would have removed everything. So within 1 point some hour, all if you imagine after 3 to 3 p.m. if you close A and B and only C is working, then how much time it will take? Which means 7 by 5 hours. 7 by 5 hour means what? 1.4 hour, everything will get removed. All the system will get empty. Okay, so because it removes 50% of water every hour. Imagine if you close at 3 p.m. A and B, then in 1.4 hour, in 7 by 5 is 1.4 hour. So in 1.4 hour, the complete system will get empty. 1.4 hour means 2 by 5 into 60 means what? 24 minutes. So 1 hour 24 minutes. Again the system will get empty. Means so 4:24. So 3 p.m. No, 1 p.m. 4 p.m. 3 p.m. So here around 4:24 p.m. the system will get empty. But here it's not like you're closing A and B at 3 p.m. A and B are also working and C is also working. So you can understand. So till if you see uh, like before 1 p.m. So if you see 1 p.m. so 0% of the tank is filled. 0% of the tank is filled. Okay. Then 2 p.m. So only pipe A was working. It would have done 25% of work. 25% of tank is filled. 25% of tank is filled. 3 p.m. 70% of tank is filled. 4 p.m. when you talk of 4 p.m. now A, B, C all are working, and every hour 5% of water will get removed. So now the work will be done is 65%. 5 p.m. then 60%. Then 6 p.m. I hope you are understanding 55%. Like this you can do and you can find when all the water will get removed. So you can understand that 70% of the tank was filled uh, at, 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 at 3 p.m. and every hour when A, B, and C, when A, B, and C, when they are working, every hour 5% of water is removed, get removed. 5% of water will get removed. So 70% of water will get removed in 14 hours. So you can calculate 14 hour after 3 p.m. 14 hour if you calculate after 3 p.m. the answer you will get is 5 a.m. So at 5 a.m. the complete system will get empty. So that is the way how you can understand the problem. So different problems can be done differently, and you can understand the relationship like this. Anyone any doubt? So you can see this. You can see this question. A and B can fill the system. A and B can fill the system in 7.5 and and 5 minutes. So two pipes are there. They are doing in the inlet pipe. They are doing positive work. So A can fill the cistern in 7.5 minutes. B can fill the cistern with 5 minutes, and C can remove all the water from the cistern. So C can remove 21 liters per minute, and C can remove 21 liter of water per minute. So 21 liter of water per minute. So I believe the relationship, please remember, 1 meter cube is equal to 1000 liters. 1 liter is equal to 1 decimeter cube. 1 decimeter cube or 1 liter is equal to 1000 centimeter cube or 1000 milliliter, where you should remember 1 centimeter cube is equal to 1 milliliter. So these things you should always remember. Either it comes in exam or it don't come in exam. So here, so if you can understand, C can remove 21 liter per minute. This they have given the speed of C, while they are given the time of A and B. So how much time the A can fill the cistern? So A can fill the cistern in 7.5 minutes, and how much time the B can fill the cistern? B can fill the cistern in 5 minutes, 1 minute. So now you can see uh, A and B, they are two inlet pipes. You have two inlet pipes. If you understand here, A and B, you have two inlet pipes like the previous problem. So you have two inlet pipes A and B. You have two inlet pipes A and B, and you have an outlet pipe called C, and you have an outlet pipe called C. They have given the speed of C, okay, as the C can remove. One minute. So so C can remove all the water in. You have two inlet pipe A and B, and you have one outlet pipe C. C can remove all the water, and the speed of C is given to you as 21 liter per minute, and the time of A and B is given as 7.5 minute and 5 minutes. So if the system is already filled and all the pipes are open, then it get emptied in 1 hour. So again, you can understand that here the C is dominating. So the end result, you can understand. You can understand the end result, that the C is dominating over A and B. You can understand the end result, that C is dominating over A and B. In the previous problem, what we saw, there also we saw that the outlet pipe was dominating over the inlet pipe. Okay, so question is that how many liters of water C can hold? So that is your question. So here they actually asking you the capacity of the container there. So, so this can be considered as very good problem. So because here they are not asking you the time and all. The usual problem when we solve the time and work problem, we used to get usual problem where time and all is being asked. So when they are working, how much time and all. So this can be considered as a good problem. Here they are asking in the term of capacity. So they are asking us in the term of capacity. So I assume let the capacity of the tank, let the capacity of the tank, let the capacity of the let the capacity of the tank is suppose X liter. Let the capacity of the tank is X liter. Just assume the capacity of the tank is X liter. And when you talk about C, C can remove 21 liter. C can remove 21 liter. C can remove 21 liter of water in 1 minute. So 1 liter of water C can remove in 1 by 21 minutes. So the X liter, which is the total quantity of the container that C can remove, will be X by 21 minutes. Hope you understood this. So instead of writing, because everything I want to write in time value, because that is a usual way, right? How we solve the problem. That is a usual usual way how we solve the problem. So here three pipes you have. So I'm putting C with plus sign. I'm putting C with plus sign. Why I'm putting C with plus sign? Because you know the reason. Because C is doing negative work in the sense that C is making water to go out, but that is dominating over the others. So I want at the end of the day, I want everything positive. So the outlet pipe, the rate at which the water is going out, I'm putting that with plus sign, and the rate at which the water is coming in, I'm putting that with a minus sign. So that will make more sense, for me to solve the problem. So now to understand this problem here, if you understand from this problem, everything is given in the term of minute. So understand from this problem that everything is given in the term of minute. So where A and B can fill the water in 7.5 minute and 5 minute, and C can remove all the water in X by 21 minute. And here it is given that the complete system will get emptied in 1 hour. So 1 hour I can say it is equal to 60 minutes. I can say 1 hour is equal to 60 minutes. So if you take a completely filled system and if you open all the three pipes, then the complete system will get empty in 60 minutes. So this part I think everyone is clear. Now what I'll do, I'll define the work. I'll define the work. In what context I'll define the work? So I'll define the work as an LCM. So this 7.5 minute. Now I want the LCM. So better I can write 7.5 minute as 15 by 2 minute. So now I'll take the LCM. I'll take the LCM. So now I'll take the LCM. What I'll take the LCM of 15 by 2. Now I want to take the LCM of 15 by 2 in order to solve the problem. I want to take the LCM. So I want to take the LCM of 15 by 2 and then 5 and x by 20. So I want to take the LCM of 15 by 2, 5 and x by 21. This is the way how I used to solve the problem. Right? Other way also I do the problem in by different method also. So other way how we can solve the problem. So I hope you remember what is the LCM of fraction. LCM of a fraction is LCM of numerator. LCM of fraction is the LCM of numerator divided by the LCF of denominator. That is the formula what we can use. LCM of fraction is LCM of numerator divided by LCF of denominator. So the LCM of this is equal to LCM of 5, 15 x divided by the LCF of 1 and 20. What is the LCM of 5, 15 and x? So that will be 15x. What is the HCF of 1, 2 and 21? That will be 1 only. So here let the work, when I'm talking about the work, let the work is equal to 15x unit. Let the work is equal to 15x unit. So every hour, how much amount of work A will be doing? That will be 15x divided by 15 by 2. So it means minus 2x unit of work A would be doing. And every hour, how much amount of work B would be doing? B would be doing minus 3x amount of work. I hope you understand it, because inlet pipe I'm putting minus sign, outlet pipe I'm putting plus sign. And every hour, how much work C would be doing? That would be 15x by x by 21. It means x get cancelled. So it means 315 units. So So here, when I'm defining the work in the term of A, B, and C, because inlet pipes and outlet pipe both are working, so I cannot put both of them same sign. So outlet pipe I put plus sign, inlet pipe I put minus sign, because at the end of the day, the system is getting empty. At the end of the day, the outlet pipe is dominating over the inlet pipe. So in 1 minute, how much the part get empty, how much the part get empty in 1 minute, how much the part get empty? That will be 315 minus 5x. So in 1 minute, how much part get increased? That will be 315 minus 5x. And you know that in 60 minutes the system will get empty. So in 60 minutes the total system get empty. So in 60 minutes the total system get empty. So in 60 minutes the part get empty. How much part get empty? So that will be 60 into 315 minus 5x, and that is equal to the total work. That is equal to the total work. Total work is 15 minutes. So total work is 15 minutes. The total work is 15 units, 15x unit. That should be equal to equal to that should be equal to 60 into that should be equal to 60 into 350 minus 5x. So we can solve this. This is 4, so x is equal to 13. 315 fours are means 1260 minus 20x. So means 21x is equal to 1260 means x is equal to 16. And that is the total capacity of the system or the container. That was what I had to find here in this problem. This was something which I had to find in this problem, and we can find it like this. If you want, we can do it by other way also, the same problem. So if you want, we can do this. Many people don't like this way to get the answer, so you can do in other way. So A and B both are doing inlet work. So A can fill the system in 15 by 2 minutes, and B can fill the system in 5 minutes, and C can remove water from the system in X by 20. So here, if you understand, now what you can do in fraction wise. So in 1 minute, you know that ultimately the C is dominating here. So in 1 minute, so you can understand in 1 minute, you can understand in 1 minute how much part in 1 minute. You can understand here in 1 minute how much the the part of system A will remove, that will be 2 by 15 part. In 1 minute, how much the part of system B will remove, that will be 1 by 5 part. So in 1 minute, how much part of system C will remove, that will be 21 by X part. So where A and B are doing positive work, A and B will fill in 1 minute. A will fill 2 by 15 part of system in 1 minute. B will fill 1 by 5 part of system in 1 minute. C will remove 21 by X part of the system, and the complete system, you can understand the complete system, where the complete system get get emptied in 1 minute. The complete system get emptied in 60 minutes. The complete system will get emptied in 1 hour or 60 minutes. So you can understand here. So here, which is dominating? The outlet pipe is dominating. So you can write 21 by x minus 1 by 5 plus 2 by 15. That will be equal to 1 by 60. That will be equal to 1 by 60. That will be equal to 1 by 60, because we are talking the term of minute, and ultimately after 60 minutes the system will get empty. So we just need to solve this to find the value of x. So we take LCM. So 5 1 by 60. Solve this. 1 by x minus 1 by 2 equal to 1 by 60. So we can solve this. 1 by x 1 by 2 plus 1 by 2. So, 1 by x will be 1 by x will be 21. So the value of x will be how you do, you get the same answer. Here, this part again, I just want to reinforce that I assume the capacity of the cistern as X liter. I assume the capacity of the cistern is X liter. This is what I assume, that the capacity of the cistern is X liter. Capacity of the cistern is X liter. So, and the pipe C removes pipe C 21 liter per minute. Pipe C remove 21 liter per minute. So the total content it get removed in, total content it will remove in, can remove in, total content C can remove in how many minutes? C can remove in how many minutes? So 21 in 1 minute. So X liter in how many minutes? That would be X by 21. So then I formulate the equation on that. Okay, everyone. So where A and B are doing inlet work, inlet pipe. So they are trying to fill the water into the system, and C is trying to remove the water from the system. And ultimately, I told you two ways, and by both the ways, we'll get the capacity of the container as 60 meters. So with this, I like to wind up the class. So I hope you have understood what all I have done in this class. If you have any doubt, please ask me. Any doubt, anyone? So I assume that your doubts is being cleared. Thank you, everyone.